So these are notes 2.5, and they're going to be on balancing equations. And the first thing we have to do is understand that there's the idea of conservation of mass. And what this means, and you've heard this very similar before in conservation of energy, and what this means is that mass cannot be created or destroyed during a chemical reaction. So that means whatever we have at the very beginning has to be the same amount as what we have at the very end. So let's do an example of this. So what these are going to be my reactants. And these are going to be my products. So in any chemical reaction, you're going to have basically two things. So reactants, things that are going to react together, and those then are going to produce something that we call a product, right? So an example of this is, let's say we have this, which is H2. So the red's going to represent H2. And so we have a number of H2 molecules that are floating around. And counting through this, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 atoms of hydrogen, 4 H2s, but 8 different atoms of hydrogen. We can also do the same idea with oxygen. So oxygen forms O2. And O2, I have 4 atoms of oxygen. So those are my reactants. I have a certain amount of mass based on the amount of stuff that I have. And what these are going to do is they're going to come together and they're going to produce basically H2O. All right, so for every oxygen, now those are going to split up. For every oxygen, I'm going to have 2 hydrogens, H2O. And still then, if I were to go through and count, the number of hydrogens that I would have would be 1, 2, 3, 4, 5, 6, 7, 8. I'd still have 8 hydrogens, and the number of oxygens that I would have would be equal to 1, 2, 3, 4. So I'd have 4 oxygens and 8 hydrogens. And so just a little mix up here. Here, instead of doing H2, I would just do H, and I would just do O for the number of hydrogens that I have and the number of oxygens that I have. So I have 8 on the left side, 8 on the right side, 4 oxygens on the left, 4 oxygens on the right. So my mass is conserved. I don't have any more on the right than I do on the left, even though what I have looks different, right? What I have over here is I have an H2 or an O2 right here. I have an H2 right here. Well, here I have an H2O. The amount of stuff that I have here in my reactants is the same amount of stuff that I have here in my products. It must be balanced. So what we could do if we were actually to write this chemical reaction is we would write it in a fashion that looks like this, where I have H2 plus O2 produces H2O. And so what I have here is I would have numbers in front of each of these. And so that's what you're going to see here when we balance equations. Is right here, how many H2s do I have? I have 1, 2, 3, 4. So I have 4 H2s plus 2 O2s is going to produce 1, 2, 3, 4. 4 H2Os. And so that's a balanced equation where I can go through and I would say whatever I have on the left-hand side in my reactants is going to be the same as what I have on my right-hand side of my products. So what we'll see when we see problems is we're going to see things that look like this. So this is a chemical reaction. It's a direct combination where we have nitrogen gas, N2, combining with hydrogen gas, H2, and it's going to produce NH3. So what I really encourage you guys to do is take what I call an atom inventory. So what that's going to look like is how many of each atom do I have on each side. So here I'm going to put N, not N2, but just N, how many nitrogens do I have? And so over here I start with 2 nitrogens, and I start with 2 hydrogens. On the right-hand side then, I start with 1 nitrogen, and I start with 3 hydrogens. So what I'm going to do is just the process of going through and figuring out, okay, how can I get these balanced? And what I can do then is all I'm going to do is I'm going to be able to put numbers here on these lines. And that's going to tell me how many N2s do I have. Do I have 1 N2, 2 N2s, 3 N2s? And so for the start, basically we imagine that there's a 1 at each position. And so if I have 1 N2, I have 2 nitrogen atoms. If I have 1 H2, I have 2 hydrogen atoms. If I have 1 NH3, I have 1 nitrogen and 3 hydrogens. So then what I got to do is I got to go through and say, okay, what am I going to do to balance this? So both my nitrogens and my hydrogens are not balanced, so the process then just becomes, okay, what do I need to do? So the first thing that I might do is I might see, okay, well, I need more nitrogens on this side. I have 1, I have 2 on the left, I have 1 on the right. So obviously my mass is not conserved. So what I'm going to do is I'm going to erase this 1, and instead I'm going to just put a 2. Now what that does is that does basically the distributive property. So now instead of just 1 NH3, I have 2. So what that means is now instead of just, I'm going to multiply, so 2 times however many nitrogens I have, which is just 1. So now I have 2 nitrogens, and then I can do 2 times however many hydrogens I have, which I have 3, so that's going to give me 6. Okay, now if I look there, okay, hey, now my nitrogens are balanced. I have 2 nitrogens on the left, 2 nitrogens on the right. Good situation, but now my hydrogens, again, are still not balanced. 6 hydrogens on the right, only 2 hydrogens on the left. So here's what I have to think about. All right, let's erase this 1 here, and what number can I put right here that when I multiply it by 2 is going to produce this number here, 6. All right, well, that's not a hard number to think about. If I just simply put a 3 here, 3 times 2 is going to give me 6. And when I do that now, I can look across and say, okay, 2 nitrogens on the left, 2 nitrogens on the right, 6 hydrogens on the left, 6 hydrogens on the right, and I am balanced. And I'm done. Going through this last example, again, if I have a chemical reaction that might look like this, where I have aluminum plus HCl, or hydrochloric acid, is going to produce aluminum chloride plus hydrogen gas. And so what I would do is I would start with a 1 on each of those empty spots. And with that, that means I have 1 aluminum on the left, 1 hydrogen, 1 chlorine. On the right-hand side, then, I'm going to have 1 aluminum, I'm going to have 2 hydrogens, and I'm going to have 3 chlorines. So what I'm going to do is just walk through this process of how I might solve this type of reaction and get it balanced. Because obviously if we look at this, I have 1 on each side on the left, and I have 1, 2, 3 on the right-hand side. So obviously we have more mass on the right-hand side than we would on the left. So some tricks that I might show you. Over here I have aluminum by itself. Whatever number I put here is going to be the number of aluminums that I put here. So I'm going to leave this to the very last because I don't care what number I get over here. I can just put that number there and balance it. The other thing then is I know hydrogen has to be a multiplier of 2, so I can't have a 3 here because if I put a 3 here that gives me 3 hydrogen and nothing times 2 is going to give me 3. So I know this has to be an even number here as well. So here's what I'm going to do. To get that to an even number, because I have chlorine of 3 here, I'm going to make this a 2 first. So there's definitely some ways that as you get better at this, you can definitely see kind of how things go together. So I'm going to put a 2 there. If I do that, that now gives me 2 aluminums. Notice I don't erase anything down here, just cross off and make it a little bit quicker. All right, that gives me 6 there. All right, because now I'm multiplying this 2 times 1 and then 2 times 3. Right? With that, again, I'm going to leave the aluminums to the very end. So the next thing then I'm going to try to balance all my chlorines. Right? So to do that, I'm going to erase this 1 here, and I have 6 chlorines on this side, so that means I need to put a 6 right here. If I do that, then I need to distribute this 6 times 1. It's going to give me 6 hydrogen. 6 times 1 gives me 6 chlorines. Right? Good. My chlorines are balanced. Those are good. Let's balance my hydrogens now. I need more hydrogens on the right side. So to do that, I need that to get to a 6. So I'm going to put a 3 here. So 3 times 2, right? Multiply those two things. 3 times 2, that's going to give me 6. Bam, those are balanced. check there. And again, the last thing that I need to do then is just over here where, again, I left my aluminum to the very end. Whatever number I put here is going to be the same on the other side. So I can put a 2 here. And if I do that, that gives me 2 there, and that gives me completely balanced. And the last thing I'm going to do is just double check. Can all these numbers, 2, 6, 2, 3, be divided by the same number? No, they cannot. They're not all evens. They can't all be divided by 2 or 3. So they are the least common denominators or least common numbers that go here. So that works. So I'm all done.